So now I'd like to demonstrate to you how we might use this ontology in practice by loading it into a database and performing some queries. The database we're going to be using is StarDog. It's a Clark and Parzier product. One of the nice features is that it has inbuilt reasoning capability, so you don't need an additional reasoning module to perform reasoned queries. So let's have a look at the database setup script. We drop and recreate the database. We set some properties up here. We indicate that the graph to be used for reasoning is named tbox, so that's where we'll have our tbox data. Down here we load our tbox data into that named graph, and we load everything else into the default graph. We just emit the named graph directive to load data into the default graph. Okay, so our database is created and contains the data from the ontology that we made before. So let's have a look at the first query that we'll perform. So this is the Sparkle for requesting all data type objects that have source of subject 1. Now you'll recall that we did not directly assert that subject 1 was the source of any data objects, nor that data objects had any source of a subject. So without the reasoning, if I omit the reasoning directive here, we should get nothing. And indeed that's the case. However, with reasoning, we have, as we expect, or as we hope, free stuff. We get the data that has source of subject 1 from the inference performed by the reasoner. Okay, so the next capability I'd like to demonstrate is adding graphs to the tbox and to the A box. So we have a new property that we wish to describe, has name. We simply want to add this property into the tbox. This little 2 or 3 liner here. To do that, or 1 liner in fact. So we simply specify the named graph that we're loading it into, which is the location of the tbox data, and we're going to add this triple, which is in turtle format. And that should just tell us that it's added 1 triple. Now we'll actually add some data. That uses that property. So we're going to give subject 1 and subject 2 names. Okay. Now let's perform a query on that name. So this is the Sparkle for selecting the data and name of all data type objects that have a source, where the source has a name with a regex match to a case insensitive string Jane. And we returned exactly what we hoped for, which is all the lane level FastQGZ data type objects that have a source of Jane P. Citizen, because that matches lowercase Jane. So you can see that adding properties to the database schema is as easy as loading a triple into the T-box. There's no need to alter tables, make sure that existing data is consistent with the new ontology, anything like that. We can simply add a new property as simply as this. The last thing I'd like to demonstrate is a slightly more complicated augmentation of our ontology, where we're actually going to insert an additional step between a source analyte and its library. So in this case, we're creating a new process that we're calling a capture process. We're asserting that it has a direct input of sample 1, a direct output of library 1, and it has this new property, capture kit, with this value. In the data update script, you notice that we've deleted the original relation between the library and the sample. We're bypassing it, if you like. We could leave that in there, it's not incorrect. It's just that now we'll only have an indirect relationship between the library and the sample via this capture process. So let's run that. So we've added that process, and the last query we'll perform is give me the data and capture kit of any data that has a source that is the direct output of a process that has a capture kit, where the capture kit matches this string here. So we're looking for exome or exon capture kits. And we get what we hoped for. Lanes 1, 2 and 3 are the output of, or have a source of, a process that has a capture kit, where the kit matches this string here. And we've returned the kit name, or the kit value here. So that's just a quick demonstration of how easy it is to perform reasoned queries and to update the schema of our ontology.